Welcome to this topic again, Electrostatics Lesson 2. We continue with our numerical examples, and example 3 says a 100 microcoulomb charge is placed at the origin, a negative 50 microcoulomb charge is placed at x equals 2 meters, and a positive 200 microcoulomb charge is placed at x equals to negative 4 meters. What is the net force acting on? Part A of the question says 100 microcoulomb charge. 100 microcoulomb charge. We have a diagram here. We are told that the 100 microcoulomb is placed at the origin. Origin is represented by O. The negative 50 microcoulomb charge is placed at a point 2 meters from O on the right. So it is denoted with A. And then the 200 microcoulomb charge is placed at a point on the left of the origin, but still on the x-axis, 4 meters. That is denoted with B. We recall that the force between 2 point charges is K, Q1, Q2 over x squared. Therefore, we are going to deal with these forces independently. Since we want the force on the 100 microcoulomb charge, and then this 100 microcoulomb charge is surrounded by the negative 50 microcoulomb and the positive 200 microcoulomb, it means it is going to experience a combination of forces. But to deal with this swiftly and well, we are going to pretend that the other charge doesn't exist, such that we deal with one charge at a time. Therefore, we shall have to find the force exerted on O, which is the 100 microcoulomb charge, due to A. So in this case, we are pretending that the charge, which is 200 microcoulomb, doesn't exist. So force on O due to A, using the formula that we have, you're going to feed in 9 times 10 to the power 9 times Q1, which is going to be 100, times 10 to the power negative 6, times Q2 due to A, so that's 50 times 10 to the power negative 6, divided by, distance is going to be 2, but squared. This is going to give you 11.25 newtons. Remember that the 50 is negative, but in this formula we deal with magnitude of charges. So we ignore the negative sign. And now we have the force. Let's see where it is going. The question is saying, what is the force exerted on the 100 microcoulomb? So we are looking for the force that 100 microcoulomb experiences due to A. 100 is positive, 50 is negative. That means the force between them is attractive. So if it is attractive, it means they will all attract one another. But let's see the direction of the force that O experiences due to A. So if O is to experience an attractive force caused by A, it means that O is attracted by A, therefore O should go towards A. Now that means that is to the right. So the arrow is to the right. Let's also get the force on O due to B. Force on O due to B, using the same formula, is going to be 9 exponent 9 times O is 100 exponent negative 6, and then B is going to be 200 exponent negative 6. The distance between them is 4, but squared. In this case, when you deal with that O due to B, you're going to get 11.25 newtons. So it's 11.25 newtons, the force between O and B. So O is the one to experience a force caused by B. If you look at this, O is positive, B is also positive, so they are supposed to be repelling one another. But if O is to be repelled by B, it means that O is supposed to be pushed away from B. Therefore, the force that B causes on O is repulsive, should be in this direction to the right. So this is also to the right, the arrow is to the right. We have seen that all forces on O are to the right. That's easy. The force on O is going to be a force on O due to B plus a force on O due to A. This is going to give us the summation of the two because they are all going in the same direction, which is the same as 11.25 plus 11.25, and this gives us 22.5 Newton, and it's positive, therefore it's also to the right. Well, example number part B, we want to find using the same question, but today, right now, we're going to find the net force acting on the 200 microcoulomb charge. Since we have the diagram already here, we don't need to go back to the original question. The 8.75 is the answer. To the left, we don't know, but let's find out. The 200 is placed at position B. Therefore, it is within the field of the charges placed at O and A. Therefore, that means it's going to be experience forces due to those two charges. Using the same formula from Coulomb's law, we shall find the force on B due to O, which is going to be the constant 9 exponent 9 times the force on B, which is 200 exponent negative 6, then O, which is 100 exponent negative 6. All of them are separated by 4 meters but squared. So force on B due to O is going to give us 11.25 Newton. 11.25 Newton, let's see where it is going, whether left or right. We are dealing with B and O. B is positive, O is positive. So if they are all positive, it means they are the forces between them, the force between them is repulsive. After knowing that it is repulsive, let's go to who or which of the charges is experiencing the force. Of course, it is B according to the question, because that's where the 200 microcoulomb is. If it is 200 microcoulomb is experiencing a repulsive force, it means that O is repelling it away, so the force should be to the left. Now this is to the left, the arrow goes to the left. Let's also deal with F on B due to A. F on B due to A is going to be 9 times 10 to the power 9 multiplied by B, which is 200 exponent negative 6, and then A, which is 50 exponent negative 6, also divided by the distance between B and A is 4 plus 2 but squared. So this leads us to an answer B and A. It will give us FBA is going to be 2.5 newtons. 2.5 newtons, let's see where it is going. So it is B experiencing a force. B is positive and A is negative, so the force between them should be attractive or an attraction force. And because B is to be attracted to A, it means that that force should be towards A. So towards A, that is to the right. The arrow goes to the right. So we have seen that F, according to the diagram, this arrow is F on to the right. F what? To the right, this is F on B due to A. And then to the left was F on B due to O. Then that means to get the net force on B, it's going to be the summation of those two forces, F on B due to A plus F on B due to O. So F on B is going to be F on B due to A. Due to A, we have got it as 2.5. Since it is going to the right, we shall give it a positive sign, 2.5 plus. Then F on B due to O, it is 11.25, 11.25. Because it's going to the left, we shall give it a minus sign. minus sign, then we get F at B in total being negative 8.75 newtons. So if you want, since it is negative, you would say F on B the same as 8.75 Newton to the left. To the left. That's the direction, and that's the net force on B caused by the charge placed at O and A.